My name is Jeff Garbus. I'm with Soaring Eagle Data Solutions. We are a database managed services company. We help IT leaders secure, manage, tune, and visualize their data. Primarily, we're database managed services, but usually we get a customer for database managed services by solving a performance issue that they've gotten stuck on one way or the other. Not always, but with a high degree of frequency. We have some training and do a lot of other things that are interesting, and we can talk about that at a future time. With us is Kevin Kline. Kevin is one of the very few people that have been doing this almost as long as I have. I was first certified to teach database performance and tuning back in the late 80s, and that's when you actually had to have done it before they'd let you teach it. I think Kevin dates back about that far. Why don't you tell us about yourself, Kevin?
Yeah, exactly, Jeff. I started my career at NASA in '86, and I got that job because I was a good Fortran programmer and also knew how to write a select statement, which was, the newest stuff
It was brand new
back in those days. And in fact, I wrote a book on Transact SQL that covered both SQL Server, Microsoft SQL Server, and Sybase's implementation. And I recall back at that time in the early 90s that I think you were the only other author that had written a Transact SQL book, except it was entirely Sybase, if I remember correctly.
I've actually done each. My early books, my first one was the Sybase DBA Survival Guide, but that was followed by Microsoft SQL Server 6.0 Unleashed. So my first SQL book was based on SQL 6, but that was my first Sybase. I think my first Sybase was on might have been version 10, might have been 4.9, but I'm not very many folks are using that anymore, and Microsoft has sort of taken over the world.
It has indeed. I have, rather than go down the consulting path as you have, I've spent many years as a DBA. And after doing that for quite a while, I thought what would be better than being a DBA is to help make tools for DBAs. So I've worked on many popular database tools over the years, currently at SolarWinds.
Well, those of us who use your tools are very appreciative, and we'll talk about that a little bit later as we start getting the root cause analysis, because your options are make your own tool, write your own scripts, or use the one that somebody else has already put together. And I do like the one that you guys have. So let's talk a little bit about why it's difficult to identify where issues are. So as you're looking at problems, if you look at the Gartner studies, the Forrester studies, one of these numbers comes directly from Microsoft. The time it takes to identify the actual root cause is most of the time you end up spending trying to get to the underlying problem. So I know that I personally have been called in dozens of times over the years because somebody has spent some number of $1 million on hardware because somebody said, if you get more CPUs, it'll fix the problem. If you get faster disk, it'll fix the problem. If you upgrade your network, it'll fix the problem. And then $3 million later, there's no effect on performance. And somebody's really trying to make sure that their job is still covered. I expect you've experienced similar.
Oh, absolutely. So frequently we see the immediate responses. Well, we have some memory slots open on the server. Let's fill those up. Something along those lines. And so that's really not what you want to do. You want to tune the problem rather than just throw a possible solution out there and spend a lot of money on it.
Yeah, I love the numbers on this slide. I'm not going to read them, except for that last one. Mean time to resolution, 80% of the time elapsed. And one of the things that drew me to starting to use tools is that I do a lot of 3 to 5 day consulting gigs, performance and tuning issues. We call them health checks. And when I get brought in, the first question that I guess asked is, what do you think the problem is? And so rather than guessing, I send a tool on ahead of myself and I look at what the tool is telling me because it looks at all the underlying information, physical storage and everything that's going on within the database. So it says here 80% of mean time to resolution spent identifying the problem. If I can do that on Monday morning when I walk in, suddenly we're working on problem resolution instead of on trying to point a finger. And it just knocks out a lot of your issue time.
Oh, exactly. We would always call it the blame game. A user would call and say, what was wrong with your server yesterday? Your database was just so slow yesterday afternoon. And I look at it from my console and it's perfectly fine. And so I start to look at that data, as you mentioned. I realize there's something wrong in the trace route. Is taking an unusually long path to find its way from the client to the server. So I call the networking people and they say, oh, no, that's definitely database. It's not us. And
Yeah.
okay, now we're playing the blame game. Now we're pointing the fingers.
And that happens at a lot of shops. I've been at a number of places that have a conference room set aside for finger pointing, and they call it a war room. And as soon as the users start to complain, everybody assembles in the war room, and the database guys say the database is running fine, and the network guys say the network is running cleanly, and the SAN people are saying our tools are showing that everything is coming back in 2 milliseconds, and that really doesn't help anybody, right?
Well, exactly. And in fact, your statistics that you were showing are extremely important. If your users are the ones who are telling you that there's a problem, you've already lost credibility, right? They're already angry that things are not working well. And so you want to actually have some kind of method in place to tell you before your end users know. If you're lucky, you'll be able to go in and fix the problem before they ever know.
Yeah, and the anger is mixed with frustration and fear because if they can't do their jobs, they're going to get blamed for it when it's really not their fault. And it's frustrating because people actually like to get things done and knock things off their plate and.
Right.
So let's talk about performance for a couple minutes. I know that when people call and say, hey, Jeff, we've got a performance issue, they generally have something particular that they're complaining about, and it's not the only thing. What do you most frequently get complained about at? Complained at about? What do people complain at you about?
General, just it's slow, or it set of reports or Power BI dashboards that we have. Yesterday it ran in 2 minutes, and today it's been running for 10 minutes, and we still don't have a response. That sort of general slowness kind of issue.
Yeah, that's actually more information than I get sometimes. It's not always it's the Power BI dashboard. It's not always it's the accounting system. It's not always anything other than, okay, everybody's complaining, come fix it. And that black box
Right.
approach is
Okay.
part of the reason that pointing the finger is very difficult, because if you don't have a specific problem to solve and you can only start solving the general issues, it just makes it difficult to know when everybody's happy.
Very true.
So, sometimes it's the little things that matter, and it's not always the users calling to complain specifically. I mean, sometimes you get called in because, well, Jeff, the batch that we do overnight, we've got an 8-hour batch window, and 3 years ago it was taking 2 hours, and now it's taking 6 to 7 hours, and we're getting kind of nervous. Can we do something about it? Sometimes it's all right, the database folks only get a certain window over the weekend to run their maintenance, DBCCs, index rebuilds, whatever that happens to be. Get the Ola Holmgren scripts in there and get them rocking.
Right.
But it's a finite period of time you're trying to fit things into. It's not always that sub-second response time that IBM's survey back in the day said you had to come in under.
Right. And depending on the system that you're working on, your individual customers would know better than I, but we can evaluate and put a price tag on how much that downtime is costing. So solving that problem is basically saving you money. And so if you have to kind of wander around with your eyes closed in the dark and feel your way around, the dollar sign rolling as we progress.
Yeah, and a lot of them are. I mean, if you talk to a CIO, those aren't often technical people. They're often MBAs who've identified, okay, this is costing us $80,000 a day in real revenue. We've got to get this fixed, and that's how they justify bringing us in, right?
Exactly.
So let's talk about solving the problem. The idea behind solving the problem is not to mask it. If you take a lot of hardware and throw it at the problem, sometimes the problem goes away for a little while. But have you ever seen that be permanent, Kevin?
No, it's, when a system is poorly written, pardon my French, but I call it sucktacular SQL. A, that's kind of a funny way to describe it, but B, SQL will suck up all the resources if you write your code very poorly. It will consume more memory, it will consume more IOPS, storage will slow down, your backups will get bloated, that sort of thing. And so just as we don't want to throw hardware at a problem as our first recourse, we don't necessarily want to let bad SQL stay in the database, because it will continue, as your database grows, your user activity grows, it will continue to be bad and not manage your resources well.
And that doesn't work for anybody. So
Yeah.
And look at this. First step in solving the problem is identifying it, right? We don't like to throw hardware at it. At the database level, I'm a database geek. I'm not a hardware guy. For me, networking is just Arthur C. Clarke's law, right? Any sufficiently advanced technology is indistinguishable from magic. To me, getting information
Magic,
off of
yeah.
a small disk is magic. Getting it transferred across a network is magic. But once it's in the database, this is just math, and I like math.
Right. Yes.
So,
Great point.
thank you. So, just our approach. Standard approach historically, I mean, before we had tools, I did this for a decade before somebody came to me with a tool that I liked. Maybe 2 decades before somebody came to me with the tool that I like. So, what do you do in real life? You have scripts that you bring with you wherever you go. You have an approach that you've used forever. And on a good day, you walk in and they say, we got a problem with this query. And that's a good starting point. On a bad day, well, the users are always complaining that the system is running slow between 9 and 10 and we can't figure out why. And I call that squeaky wheel tuning. This person is yelling, they have enough political clout to bring in help and to scream for it, and they get you to come in and take a look at it. Similar for you? Well, that's why
Yes,
you next said
indeed.
that's why you got into building tools, right?
Exactly. Yeah, I started that in January 1st, 2002 is when I started in the tools business. But just like you said,
It's a while.
tuning the squeaky wheel, that might solve one complaint, but what if that is a complaint solely because it comes from the most powerful person in the office?
Mhm.
So I used to work for a partnership, and sometimes the partner would call and say, my report is slow. And I'd start to look at it, and I'd see that it's so slow that this partner's report was slowing down all the end users. So really, the enemy is us, as the old comic book cartoon Pogo used to say.
Yeah.
So you are fixing what is urgent, but not necessarily fixing what is important,
Yeah.
because no one complained about the important thing.
And then to make it worse, what we find in real life is that developers like to write new code, but if there's something that does most of what they want, they copy and paste it and make small changes to it. So what I see a lot is I'll take a look at some bad code. I'll say, this is how you fix it. And then somebody will look me right in the eye and ask, do you think I should fix the other 40 or 50 that do it exactly the same way?
So true. Yes. I've seen that happen many times as well.
And they'll look you right in the eye. Yes, of course, fix the rest of them. Of course, fix the rest of them. So some of the things we look for, I always start looking at I say I'm not a hardware guy, but I know how to identify when a problem is hardware and how to quantify it. So I start looking at stats that have been gathered on I/O, network, CPU, and I look for a bottleneck there because I can also at that point say, okay, if it looks like this is pretty I/O bound, it might be time to start looking at indexing. If it's network bound, I might look at application which is shipping a lot of information across the network, etc. But at that point, we start moving down to that micro level, which is, okay, which queries are using the I/O? Which queries are using the CPU? Which queries are using the whatever? Your approach similar?
Absolutely. Typically, there are four major domains at the macro level, as you pointed out. We have CPU, we have I/O, we have memory, and then we have network. And usually, in my experience, with OLTP systems, it could be different with analytic systems, but usually it's something like the storage subsystem is quite slow, or it's people stepping on each other's toes to get to the storage system. That's the most common one that I experience. And then followed by memory and network, not as much, but that does happen. And when it does, it's an extreme problem typically.
Yeah, but nice to be able to identify it because each of these groups always says it's not us. And one of my new favorites in that area
Right.
are people who have gone to Azure and say, well, we're paying for 80,000 IOPS. And I can look at it and say, okay, I can demonstrate that you're getting a little bit less than spinning disk speeds. And
Yes.
once you show people how that gets quantified, becomes very, very interesting.
Mm-hmm.
So as you get to the point where you can start looking at these things, it really is interesting what bubbles up to the top because often it's not what people are expecting to see. If somebody is throwing CPU at a problem, if it's not CPU bound, suddenly they're paying a lot more for their licensing, not only for their CPU and for their hardware, but for SQL Server because the SQL Server licensing is mostly CPU based these days, right? Core based.
Mm-hmm. Right.
And
it's even worse, actually, Jeff, if you're running on an Azure-based system. As you pointed out.
Oh, yeah.
I shouldn't say Azure. I mean, any of the cloud providers, because there you pay for consumption, not, that fixed cost of your server. So if you overspend on a server every 3 years, that hides a lot of, poorly coded SQL and things like that. But if you have a lot of poorly coded SQL, you go to the cloud, you're spending a lot more money than you need to because you're using a lot more CPU, you're using a lot more storage, a lot more IOPS, and you have to pay for each of those according to how much you consume.
Yeah, and the other piece of that same puzzle is that when you're getting ready to go to Azure or AWS or Google or whichever your cloud provider is, they often have tools that will run against your system and say, okay, Azure should cost you X amount per month. And when it comes in at triple that, you start scratching your head and going, were they lying to me or is something awry?
Right.
I'm not going to give you the cynical answer to that one, but it's often because something is awry.
Yes.
So as we start looking at fixing performance issues, right? I know that my approach has changed a little bit over time. In the olden days, I would use which queries are the worst and start fixing them. And worst queries not necessarily the one that are driving the users nuts first, but the one that's using the most resources. So if I've got a query that's running 50,000 times a minute and it's running in 1 second, the users are probably not complaining about it. But if you tune it down to 20 milliseconds, suddenly the load on the server is down a lot. But when we talk about fixing the performance issue, we're talking generally, we don't want to do it at the hardware level. We do want to double check the server configuration because as you mentioned the other day to me, there's a lot of people who just install by going click, 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 click. And
right. Next. Mm-hmm.
Yeah, and the basic, talk for a minute about how the basic installation, the default installation, has got a couple of problems in it.
Oh, indeed it does. Configuration settings, as you mentioned there. Now, they have fixed a few of these default values in the most recent version of SQL Server. But if you are using anything besides the very newest version, you'll have issues where, for example, you mentioned lowering max degrees of parallelism, DOP. So by default, that is set to 0 in SQL Server, which means use as many CPUs as you have access to parallelize a query, to split it across all the different cores. And it goes hand in hand with another setting called cost threshold for parallelism, which by default for many releases was 5, meaning the cost of the query, according to the execution plan, was a very low number of 5. And that means that you have a lot of queries that are being needlessly parallelized and perhaps starving other processes of CPUs. So that as a default is not a good one.
Yeah, and I know.
And in fact, oh, I'm sorry. Go ahead, Jeff.
No, you finish your thought. You paused for breath, and I jumped in on it. So you're allowed to breathe.
No, no. Well, and I think we'll touch on this a little bit later. But one of the other things that I see happen is, let's say you're a system admin, you're in a small shop, maybe you're the network admin, and you're not really tuned into all the nuances of SQL Server, and it gives you optional services that you can install as well as SQL Server. So there's analysis services for your analytics workloads. There's integration services for data engineering and data pipelines, reporting services. And so there are quite a few times when people just continue to hit the next button and install all of those services, even though they really only need SQL Server.
And they all take memory, and they all take resources, and they all take storage, and they all take CPU. It adds up.
Yes.
So I like tools. I do like SolarWinds DPA a lot, and that's one of the tools that you've been working with. I know a good chunk of my first career was SQL Server. I wrote my own, and the first time a software salesman took me to lunch and said, "Jeff, I'd like to talk to you about this." I said, "Well, I'm a consultant. I have to accept a free lunch," but I really wasn't very open-minded. But yeah, they take your union card away, right? If you don't accept the free lunch. But I was extremely impressed with the capabilities of a tool that's gathering information every second and just giving you the ability to slice and dice it, because there's a lot you can do with it. The very first time I sat down and used it, a lot of things went on. The other piece of this is that even if you're really good with the system tables, with the DMVs, with the whatever, every time a new version of SQL Server comes out, I've got to change or monitor or check my scripts. It's much easier for me to have Kevin Kline take care of it for me.
Right. And the same for me. Many years as a DBA, I had developed these useful tools, transact SQL scripts and so forth, but maintaining them. Every time there was a new release of the data platform, it was hard. It took a lot of work. And that's part of the reason why I gravitated toward commercial tools, because you don't have to worry about that anymore.
Yeah, and speaking of that, it is an unusual shop today that has 100 servers, and every single one of them is running at 2017 or 2019 or you name it. We're going to be onboarding a new managed services customer in the next week that has 2008 and 2012 and 2017 and 2019, and all of the little roll-ups in between. Well, guess what? Are you going to point the right version of the script at the right server the first time across a couple hundred servers? Again, much easier to handle.
Yeah, don't want to throw shade on anyone, but that's kind of a nightmare maintenance scenario.
You don't always have a choice, and you don't always have the resources to get all the things done that you want. But if you have the right tools, you can take care of the servers that you've got. So here's why I like DPA. It does trending analysis. It picks up a lot of information that you need to with both real performance issues and perceived performance issue. What's a perceived performance issue? Things like blocking, things like sending large data sets across a network. One of my personal favorites was an application that brought 800,000 rows of data to the front end and displayed 6 rows.
Whoa.
That was a real life example, 872,000 rows coming back. But let's actually just
That's
start
spectacular SQL right there.
that is a bad approach. But
Mhm.
what we're going to do, let's actually just start looking at some examples and some things that you pick up and some things that you can look at and take advantage of and do some real finger pointing now, because we've been promising this for, 25 minutes, and I'd like to start digging in.
Yes.
So the first one I have here, you mentioned that there's 4 places that you start looking, right, for resources: CPU, disk, memory, network. This one here I
Mhm.
grabbed page life expectancy. This one is an indication of memory. If you look out on the web, there are thousands of white papers that represent and misrepresent what this actually does. Do you want to speak to it first?
Well, by default, SQL Server will keep a 8K page of data in the data cache. Uh, by default, it tries to hit the number 600, which is 5 minutes. However, as our databases have grown in size, a value of 600, let's say if you were to write an alarm just to watch that, for most databases on a modern piece of hardware, your number should be much higher than that because you have enough RAM to store quite a lot of your database in cache for much faster access.
Yeah.
And so your note there is spot on.
Yeah, let's say you hope you have enough memory to store a lot of your database, right? If you're running a terabyte of data on a SQL Server standard, you're not going to get nearly as much access to nearly as much memory as you might hope.
Absolutely. And on top of that, as we had discussed a minute ago, if you're also running reporting services or analysis services or any other non-SQL Server services on your hardware, then they will consume a couple gigabytes each typically. And so you lose memory to other processes.
Yeah, and for those of you who are not database geeks like Kevin and I, uh, as fast as your storage is, it doesn't really matter about the page life expectancy, because all the operations have to happen in memory. We don't perform any operations on the disk. We bring it off the disk, bring it in memory, all the operations happen there, whether it's read, write, anything else. So as we're looking at this
Mm-hmm.
particular server, we're looking at it across time. We've got about a week here, and it's always down in the now almost always down below the 280 range. I just picked one of those numbers at random to bring it up. And for this particular group, they're experiencing all kinds of issues. And the first place I looked was here. And I said, well, the first problem you're running into is that your memory's starved. And they said, what do you mean memory starved? And I walked through all this. And I said, if you look at the white papers are going to say that you want a PLE, page life expectancy, above 600. But in real life, I like to see it above 10,000. That's a personal
Mm-hmm.
preference, and I'm sure there are other people as experienced as I that might have different preferences. Do you have a number that you like to pick? Where you're going to tell them it's problematic?
No, I do have a number. It varies though. The correct answer to all technology questions is it depends, right? And so it
Absolutely.
depends on how much overall memory you have for SQL Server as a ratio compared to the size of the database. So it could be 1,000, it could be 4,000, it could be 10,000. So for me, it's kind of a moving number according to how much RAM, how big is the database. But one thing I would like to throw out there as well, Jeff, is that many generalists, I find, if you go to Stack Overflow or Reddit or any place where you can ask a question, the Microsoft SQL Server forums, you'll see a lot of people saying, oh, my SQL Server is so weird and inefficient because every time I open Task Manager, I see that it's consuming every available bit of memory. And long story short, if you're using Task Manager to try and troubleshoot SQL Server, you're doing it wrong.
Yeah,
because it
absolutely.
doesn't understand. Yeah. So I'm sure you've seen that as well with your customers.
Yeah, task man, it just doesn't really matter because SQL is going to grab as much memory as it can and it's going to keep it. What we're looking at here really is, are the pages that we're referencing frequently staying in memory or getting pushed out? If they're getting pushed out because the PLE is low, you've got a lot of extra IO going on, and if it's staying up in there, you're good. And as you mentioned, it's how much data are you using? I mean, you use the as a reference point size of the database, and I'm going to modify that slightly because it's the amount of data you're using. So in a lot of organizations, you got 20 years worth of historical data in your database. What are you
Right.
using the last
Right.
year or two or three? But that doesn't necessarily help because you've got these big indexes now and you want to keep as much of those index structures up in memory as you can as well.
Hmm.
Disk queue length. So let's talk about what disk queue length means. The disk queue length is the number of IO operations that are sitting at the controller level waiting for completion. So I want a page, I look in cache, it's not there. Uh, I push this off to an IO request. Now that's expensive because not only are you going for the physical IO, which is about as expensive as you can get, you're also swapping your process out while waiting for that IO to complete. Anything to add to that one?
This is one where you do have to be careful a little bit too, like PLE, because it depends a lot on the hardware you have behind the scenes. So if you have SAN, then the SAN might have caching. And then you
Yes.
might have the Windows server that sees its what is it, HBus adapter, the hardware input output subsystem. And so it has the cache. So you might have two places at which you have a possibility to queue. So again, like you said, it's something that you need to keep an eye on and understand a little bit more than just the basics of how a computer works.
Yeah, it's the basics of how the database works that's more important here, right? So as I'm
Mm-hmm.
looking at this, I'm a database geek. I am not a hardware geek. And as we
Right.
track down hardware problems, I listen and pay attention, and I hear the words, but I don't pretend I understand everything that's going on behind the scenes. I mean, I know what SAN caching is, right? But what do you do about it? From my perspective as a
Right.
database, yeah, exactly. So I look at this and I say, okay, between 9:20 and 9:30, which is when everybody was calling up and saying we've got a problem, I
Right.
had a severe hardware bottleneck here. And how do I know I have a hardware bottleneck? Because I was not getting the pages from the disk at the rate that I needed to, as defined by
Mm-hmm.
Microsoft, who says, you know, if you're above 2 for 10 minutes, you probably have a hardware bottleneck. And here we're exceeding 200,
Mm-hmm.
which is kind of high.
Right. Right.
And I'm going to move a little bit faster because I've got about 20 more slides and we've only got about 25 more minutes. So uh,
Sure.
we've talked through disk queue length, the idea here being that we have a hardware bottleneck. One of the cool things that a good tool does is correlate this hardware bottleneck with other things that are going on. Uh, is our network slowing down? What queries are we running at this point? So I know that if I'm trying to debug this, it's really nice to be able to say, okay, I've got this hardware spike here. What queries were running at this time and be able to just go in and drill down to that particular point.
Right.
I'm going to skip the next disk queue length slide and talk about blockers for a minute because this isn't a database performance problem. Really, it's a perceived problem, which is more application related. Do you want to go with this one?
Well, absolutely. You know, reader client will not block other readers,
Mhm.
but if someone is writing data, maybe they're doing an update statement or an insert or a delete, any page that they have as a part of their transaction blocks everyone else. And so if that person isn't quick about completing their transaction, especially if the developers have written their application code in a way where it keeps the transaction open until there's some kind of response from the client,
The
you could
worst.
have lots of, yeah, it could be a massive blocking chain of people blocking people blocking people, just because someone didn't click OK when they were finished making all their changes. So it could be a disaster if not carefully managed.
And that is actually one of the things that gets picked up by this tool, those idle blockers, the concept of creating a lock and then not closing it out and just waiting for something to happen. There's no CPU spinning,
Mhm.
but this process is blocking. And we have the ability to help track that down, which is has saved a lot of time with a lot of my clients. Moving into log weights. So one of the problems that you run into is at the database level. So you've been a DBA for half of forever. I've been a DBA for half of forever. Actually, if you just consider the lifetime of SQL Server, I'd say 3/4 to 9/10 of forever, right? And over the course of that time, you run into problems, you get burned by those problems, and you build a process around it. And this was the first tool that I saw that gave me access to a problem that was recurring in an easy way. So do you want to define a VLF? Would you like me to?
Well, a VLF is a virtual log file. And so SQL Server, as it's writing transactions, it writes as a transaction log. And if it has to grow, you probably have the default setting of auto growth, which means it'll add a small amount of additional space. And it will have to auto grow over and over and over again. Each of those auto grows is a VLF. And so the biggest I've ever seen that number grow to is between 50 and 60,000. How about you, Jeff?
We saw one once up in the 400,000 range, and that was certainly an anomaly. But as you start thinking of the numbers that Kevin and I are throwing around, be aware that you can start running into problems with VLFs in the 20 to 80 range. Not 20 to 80,000, but 20 to
Yes.
80 VLFs. And the reason for that
Mm-hmm.
is every time the SQL Server tries to commit a transaction, it looks for the best place to do it. And these virtual log files were a great concept because it gives you multiple entry points into the log. So 2,000 people all hitting commit at the same time, all hitting enter at the same time. If they're all trying to write to the same log page, you've got a serious hotspot, right? But if we have multiple entry points, we got multiple hotspots, and that's going to save a lot of blocking. But if we're going to spend 2 seconds or 5 seconds trying to find the right VLF and then spending 2 milliseconds trying to write, there's a disconnect there, right?
Absolutely. And it gets even worse if you ever have to restore a database, including the transaction log restore. I had one customer that had a 2 terabyte database. It took many hours to back it up, many hours to restore. And they had, again, they had in that close to 50,000 number of VLFs. So we rebuilt it so that it just used, in their case, they had 4 VLFs of many gigabytes in size. And it dropped the time to recover a database. And this is the time at which the CIO is pacing around in your cubicle and glaring at you. But
And everybody else
it
is throwing
reduced,
things at him or her, right?
right. And it shaved 2 hours off the recovery time. So significant improvement when the chips are down.
I would say very significant. And then the other piece of it that I really like having a tool for is that you can look at history. So if you get a spike, here we have a spike in the memory paging rate, right? Well, is that normal or is that an aberration? Well, we can see that it's happening at a particular point in time, but the ability to go look at this historically from my perspective is pretty critical.
Mm-hmm.
Why don't we talk about weight type analysis for a minute? You want to take a whack at this one?
Yeah, absolutely. So weight statistics are important to most all relational databases. Oracle has them, Postgres has them, SQL Server has them. And although the specific names for each of the weight categories vary, they basically tell us how long a process is weighted to complete, and in what was the general cause. So you might see, for example, in SQL Server, it tells you that you have had processes wait due to locking for a read transaction, or processes locking for insert operations. It could be something like you're waiting on network I/O. So it really helps you to understand, in this case, the number one there is memory and CPU. So you could see by looking at the wait statistics, am I working on a solution that's in the right ballpark? So that old example that we've used of throwing more cores into the box, if you don't have a CPU or memory related issue, that's not going to help at all. So it really helps you make sure that you're working on the right problem.
Yeah, that's right. And the example I use is, let's say we're just selecting 100,000 rows from a table, right? You got some amount of time spent getting the data off the disk into memory. You've got some amount of time identifying that we've got the right rows, and some amount of time shipping the data back to the client. Well, so you've got some network time, you've got some I/O time, you've got a little memory time, plus you've got the processing time. And if all the time is being spent at the network level, you can tune that query forever. The only way to fix it is to reduce the number of rows in play. If you're spending all your time in I/O, well, guess what? You can tune the query forever, but unless you have a faster I/O device or more memory so that it gets cached faster, you're kind of out of luck. So I think you've hit that nail right on the head. So trending becomes important. We've talked about these concepts, and we are running a little low on time, so I'm going to move forward a little bit faster. Let's talk about network just for a moment, because one of the things that happens with a high degree of frequency, in my opinion, and high is some measurable percentage of the time. I'm not saying this is 80, but 10% of the time, the network people are going back and forth with the database people, and the database people are saying the network's slow, and the network people are saying, my tools are showing that this is flying like a son of a gun.
Yeah.
One of the things that SolarWinds does is ping the DBMS. So from the SolarWinds tool, you have effectively a SQL client open, and it does a select one, which is going to happen instantly because that's all. There's nothing there to do, and it goes out to the database, comes back with the one, and guess what? Now you're measuring how much time it took to get back. Now, in most environments, what I've found is that this will come back if you've got DPA running in the same physical room as your database server. These are pretty much zero uniformly. I mean, it just rounds down and there's no elapsed time. If you're running on some sort of virtual machine, regardless of the vendor, it's typically about 1 millisecond all the way across, just for the ping time. And again, these are rounding things, right? And if it's above that or you're getting spikes, there's something you may need to explain. Your experience is similar?
Yes. The only time I've seen it vary is on the 1% of the highest performance OLTP situations. So in one case, we worked with a customer that had a workload that included tens of thousands of concurrent users, hundreds of cores on the box, and things were slowing down due to network, but it was mysterious. We had difficulty troubleshooting that and getting to a root cause. And what we eventually came to learn was that what was happening was there wasn't enough OS CPUs available. They were all working on SQL Server, so the OS CPUs were not available to process the working networking load. And so we used a setting called CPU affinity, which really very few cases you ever need to use this. But what it did is we set aside 2 CPUs just for networking. So so we could manage all that. And when that happened, the NIC was able to handle the workload, and things got much better. But
Yeah,
generally, that's an edge case.
it's an edge case, but guess what? If you don't have a tool that's showing you that it's network performance on the database side, do you even think to look at
Right.
that? I mean, it's a much harder thing to track down without this. And I'll mention one more thing. Because this is a ping of the DBMS, if the CPUs are running at 100%, this can be off by a little bit. But one of the things that we find with
Right.
SQL servers, SQL Server tends to run fine if the CPUs are at 98 or 99%. But when you hit 100,
Hmm.
suddenly there's a wall.
Very true.
Yeah, this is a great discussion tool. Again, always look at the scale. If we're spiking up to 2, 3, 4, probably not a huge deal. I was at a client once where this was all in the 300 range. And the
Ooh.
client said to me, you know what, Jeff, I've been trying to explain to network for months that things are slow and they keep telling me no. I now have quantitative proof, which was really nice.
That'll end finger pointing very quickly.
Yeah, as soon as you can show somebody a graph saying the SQL server is not getting what it needs or it's taking too long, it's much more important. And you know, when you get into, I mean, a lot of our attendees here are healthcare related, and when the doctors are calling in
Mm,
complaining, uh, I can't get my patient records up, I can't. The cardiac
mm,
machines are running slow, and everything's running on SQL Server these days, right? Becomes
hmm.
really important to know that you're solving the underlying problem. Let's talk about CPU a little bit. I love this particular view of this particular set of resources, and I'm going to go first because it tickles me, and then you can add to it whatever you like. What we're looking at here is first instant CPU versus OS CPU, that top right versus the bottom left. And if this were my product, I would probably change it so that I've got instance above OS, simply
Mm,
because I like to compare those two because those should be shaped the same. If they're not,
right.
right, if they're not, it means something is running on the computer or on the instance on the virtual machine that is not SQL Server, which is not a recommended practice. And it hasn't happened in the last few years, but in the olden days, I used to get that a lot, that somebody would say, only SQL Server is running on the box. And I would point and say, what's this?
Yes. We even had a customer who they had outsourced their administration, and suddenly things were not finishing in the preventative maintenance window every night. We looked. They the admins did not realize that SQL Century or DPA was on that box, and it turns out that the admins were running a Bitcoin miner, thinking that nothing's happening at night. So yeah, so they were trying to make money on that.
That's interesting. I've been at, I don't know if I should say this on a recording, but I will. I've had two separate clients that found their admins running porn sites from when they're within their financial or healthcare applications uh, without anybody knowing until a tool that was monitoring picked up on that. But
Wow.
once was an aberration, two was, oh my God, I can't believe this is happening.
Right, indeed.
One other thing I really like about this one is the signal weights percentage. And the signal weights is an indicator that we've requested a CPU and can't get one. And what does that really mean? Well, we can see that the instant CPU is low. Why would the signal weights be high? You want to take a whack at that one, or would you like me to?
Go ahead. Since we're running a little short on time, let's run through that.
Sure. The idea behind the signal weights is that if you're running a process in parallel, if the SQL Server says, I want 8 cores, 8 threads to run, then it will wait until 8 threads become available. So if you're running any process which is hogging a thread or threads aren't available, or particularly within VMware environments, you can't get all the threads you're looking for, then you're going to get a wait. So this is an indicator to us to drop your max stop. But we found a really cool one, about 2, 3 months ago, where we dropped the max stop down to 1, which is, hey, you can only get one anyway. We're still experiencing signal weights percentage, and we were able to use that as a smoking gun to figure out that the virtual machine had not been configured
Mm,
properly, and it was not able to get
right.
to the CPUs that wanted.
Mm-hmm.
So again, running low on time, I'm going to speed through this a little bit. So as we talk about queries, um, it's important to get the slow running queries that the users are complaining about. That's a good place to start if you're doing a tuning exercise and if you can identify them. But the other thing we like to do is identify heavy hitters. How do you identify a heavy hitter? Well, a good tool, SolarWinds DPA is a good tool, identifies all of that user experience time that we talked about and adds it up. So we can say that a particular tool here between 3 and 4 p.m. was using a large amount of time. And what I like to do is just start from the top and tune the first 5 or so. And then once those are tuned,
Right.
get started with the next ones. Here,
Mm-hmm.
as we're looking at this graph, the write log time, that is that VLF issue we talked about. And we often find that if we correct the VLF issue, all of that write log time goes away, or it goes down to something which is difficult to measure, which is equally good. Any
Mm-hmm.
comments?
I know.
Okay.
Spot on. I'm thinking the exact same thing. Mm-hmm.
Great. Historically, another great thing I like to look at. Well, yesterday everything was running at 100 milliseconds, or here we see 700 milliseconds. Next day it was 500. Next day it was 400. And this is the average wait time. Well, the cool thing about this is where we've gone through a tuning exercise, and late on the 27th we'd fixed the queries, and guess what? Average wait time now is tiny fraction of what it was before. But
Mm-hmm.
even if you're not doing this, one of the cool things that it gives you is the ability to compare the number of executions with the wait time. So when your client says to you, well, we've just bought 3 of our biggest competitors and we're going to quadruple our throughput, what do you think is going to happen? Well, we can take the busiest queries and look at this and say, all right, well, when you go historically from 1 million transactions a day to 3 million transactions a day, your wait time doesn't change. Or worse, you go from 1 million to 2 million and your wait time doubles or triples. Well, guess what? Scaling is going to be a problem, right? Execution volumes. This is a cool thing to trap as well. I know that for me, going from one execution, which is taking a long time, versus 34,000 makes a big difference. It's also nice to pick up on this logical read count, because if I can take a query and tune it, my personal favorite was 1 trillion logical reads an hour, down to 30,000 logical reads per hour. That was one index, by the way. Then you know you're going to have a positive effect on the system. And again, sorry, just trying to keep time in here as we're looking at this. Very important to pick up volume, very important to look at scale, very important to be able to determine values. So you go through a tuning exercise and people are asking, is it faster? Well, here's a before picture. Note the scale. We're going out to 170 seconds here. Note the
Mm-hmm.
scale for the same 10-minute time period. Now we're going out to 5 seconds. And the only thing we've got to fix now,
Yeah.
with the write log barely
Mm-hmm.
showing up, now suddenly the write log is up there and say, this is the issue that's popped to the top.
Mm-hmm. Yeah, that's a dramatic improvement.
Yeah, I like to tune. Good before and afters. This was one of my favorite before and after pictures. And this was one of those, we sent it in a week before we came in. Monday morning, we came in and took a look at what these big heavy hitters were that were crushing the system. And as a joke, the CIO came in at 10 o'clock in the morning and said, so Jeff, have you fixed our problem yet? And I said, no, but we've identified what the issue is. We can fix it right now if you want. He said, show me. And I did. And people started calling. And this was the change in performance. One of my favorite pictures of all time.
So on October 20th is after all the tuning was completed?
Yeah, well, we did it in the middle of October 19th. So I was there on October
Mm-hmm.
19th. lunchtime, we put some indexes in, and this was the difference between the 19th and the 18th, and then the rest of the week, everything was just swimming.
Yeah, that's, again, dramatic results.
Yeah, it's very cool to be able to make the changes and demonstrate that the changes were effective. There have been occasions over the years, not a lot of occasions over the years, but there have been occasions over the years where we've tuned at the database level and demonstrated that it's 10 times faster at the database level, but the users aren't experiencing a lot of change. Well, that's the time to go back to your resources and say, okay, this is not a database issue.
Right. Right. Got it.
All right, so we've got about 3 minutes left. I'll go over if we have questions or people who want to ask or anybody who wants to get involved in a chat. And I'm not seeing anything pop up in the questions window, but I will make an offer to everybody who's listening to this now, and that is a lot of you have downloaded a demo version of DPA. Many of you have access to it. I've been doing this for a very long time, and I've been working with DPA for, you saw a DPA screen on there from 2012, so at least 12 years, and I don't think that's, I think I've been working with it longer. Anybody who buys this who's interested, I will spend an hour with you after the installation and talk to you about what DPA is showing you, what it means, walk you through how to use it. You just have to reach out and ask, how do you reach us? The contact us is down there below. Soaring Eagle does resell the software, and SolarWinds is happy for us to do that.
Thank you. In fact, not only do I thank you, but my children thank you. So helps pay the mortgage.
Please tell your children they're very welcome, and I'm happy to get involved. And
yeah, fantastic. And folks, let me just add to what Jeff is saying is that great consultants are hard to find. People who really have thorough knowledge of the system, its internals and its architecture, they're not common. And so an offer for some free time with Jeff is extremely valuable. I really do encourage you to take this up as a potential solution to many, many problems and a way to accelerate adding value to your business. Most of us, when we have to deal with IT problems, that's not making us better at what we do to earn a profit. At the end of the day, it's just the table stakes to stay in the poker game. But when you have somebody like Jeff and his team, you can do so much more and focus so much more of your energy and attention on the next release of the software that you run. Or maybe spending some time figuring out, can we apply analytics? Or you're probably hearing all the hype about generative AI or things like that. So this enables you to focus on what can make you perform better or your organization perform better, and let Jeff and his team take care of all of the things that are holding you back from that, rather than spending all your time just trying to get back to that kind of barely acceptable level of performance.
Thank you, Kevin. I appreciate the kind words, and we will do our best to live up to them. And if we can reduce stress, that is our role as consultants. So we like to do that stress reduction. So I'm not.
And if you don't mind, I'll put in one more word too. So one of the services that Jeff offers is called Managed Service Provider. And so let's say you're a small or medium-sized shop and you do have one or two people who are very good at being the data administrator or database administrator. Or maybe they're your most knowledgeable developer who works with databases. Well, what happens if they want to take a vacation? You've got no one, because that's the person who solves your problems when it comes to database. So again, this is a service that Jeff offers in which his team will take care of the management of your system. And so that's another great service that I recommend to smaller shops or shops that have grown big enough to have maybe one DBA. But at the end of the day, that means that one DBA is going to be very hard pressed to find time for being a human being, right? They'll be overworked, they'll get calls at night and so forth. So Jeff's team can really help augment that ability to keep things maintained. So yes, tuning engagements are excellent, but then also just the general care and grooming and maintenance of your systems so that your team it has that reduced anxiety. They can take vacations at appropriate time. They can enjoy the holidays without worry. So that's another great service that Soaring Eagle provides.
Thank you for an awesome segue. We actually have customers with 5 to 10 DBAs who use us because that way their DBAs can focus on their business specific needs instead of keeping the lights on and tuned and running and functional and highly available.
Right.
All things that we've got a lot of
I think
experience at.